myself, Dr.G.Valarmathy, Associate Professor of Chemistry, Sita Lakshmi Ramaswamy College welcomes you all to the e-learning platform of SRC. We are going to see an outline about Heck reaction. Heck reaction, actually it is a palladium catalyzed cross-coupling reaction. The cross-coupling between organohalides or triphthalates with olefins in presence of a base. It is a Nobel Prize reaction. It was awarded in the year of 2010, awarded to Heck along with Negishi and Akara Suzuki for developing or for forming a C-C bond between halogen bearing group and sp2 carbon of the olefin, and it is a special reaction in which a platinum palladium catalyzed cross coupling reaction. Here the reaction between an iodobenzene with a styrene in presence of a palladium catalyzed reaction, here to form a C-C bond, a new bond is formed between these two compounds, which is awarded a Nobel Prize in Chemistry in the year 2010. Fujiwara in 1967, he reported the coupling of arenes and alkenes by palladium-2, and Heck in 1969 demonstrated the coupling of aryl mercuric halides with alkenes by palladium-2, and Misoroki in 1971 developed the coupling of iodobenzene and styrene. For that, they awarded the Nobel Prize only in 2010. So Heck reaction is a coupling of an alkene with a halide in presence of palladium-0 at oxidation state as a catalyst to form a new alkene is known as Heck reaction. So this is a formal Heck reaction. This is a basic one in which this iodobenzene reacts with this styrene in presence of this palladium acetate with a 0 oxidation state to form a C-C bond, a cross-coupling reaction between this. And instead of palladium, in addition to that, palladium phosphine ligands can also act as a catalyst in such reactions, which forms 85% yield. When you compare the yield between these two reactions, this is 75%. When you use phosphine ligands, we will have 85% as a yield. So what are the catalyst and bases used in this Heck reaction is a very interesting one. See here, the typical catalyst is tetrakis triphenyl phosphine palladium-0, palladium chloride, palladium-2 acetate are the typical catalyst used in this Heck reaction. And the ligands such as triphenyl phosphine, phosphinoxylenes, and 2,2 bis diphenyl phosphino 1,1 dinaphthyl BINAP. BINAP is a famous ligand which is used in this Heck reaction. And the typical bases used here, it is a triethylamine, potassium carbonate, K2CO3, and sodium acetate used as a typical basis in the Heck reaction. So now let's see the outline, that is pictorial representation of this Heck reaction, which involves 4 steps. Step 1 is the oxidative addition. Step 2, insertion of olefin. Step 3 involves beta hydride elimination followed by reductive elimination. Step 1 involves oxidative addition of the alkyl halide with the platinum catalyst, that is PtL2. Here we will have one Cl and L, in which this palladium is in 0 oxidation state. And the next is followed by the oxidative addition. It forms the product with the oxidation state palladium-2. And step 2 involves insertion of olefin. Olefin acts as a starting material in this reaction to form an intermediate in which it involves the hydrogen, that is beta hydrogen elimination, leads to formation of a new product. And then after this beta hydride migration, here it has the palladium catalyst in which it has an oxidation state 2. The base that we are adding, which involves a reductive elimination, which eliminates this HX molecule, again this catalyst palladium, that is PD with a 0 oxidation state, is ready for the next cycle. Here what the purpose is, Here the use of this palladium 2, that is the base, in which it will act as a eliminates the catalyst in such a way that will form again this reaction will continue. See, this is the step 1 is oxidative addition, and it is a concerted mechanism actually in which this palladium 0 is oxidized to palladium 2, and then when palladium 0 it reacts with Rx to form this 2 oxidation state. And the next one is insertion of olefin and this internal rotation. So the insertion followed by the formation of bond between one carbon of the olefin with this product to form an intermediate. And the next one is beta hydride migration, in which this is alpha and this is beta. This beta hydride migration leads to formation of an olefin with again this platinum 2 with the oxidation state. And the last one is reductive elimination, is nothing but this base regenerates. The base that we are using is regenerates the platinum 0 catalyst, thus continuing this catalytic cycle again it forms. So the oxidative addition of Rx on palladium 2 complex to form PD2 having an sigma alkyl bond. Such complexes are very reactive, especially towards olefin insertion. The role of a base is to remove the HX formed during this reaction. After reductive elimination, palladium 0 with oxidation states is regenerated from palladium 2 complex, and it is now ready for the next cycle. So this is an application of this Heck reaction in which we can have this drug, anti-inflammatory drug, naproxen. For this only they had awarded the Nobel Prize, synthesis of these sunscreens, and by using this Heck oxyarylation for these compounds they had awarded the Nobel Prize in the year 2010. Let us all see the next Nobel Prize reaction in the next video. Thank you.